This then is the 3.4.2 unit looking at radiation. Again, this is the sheet that you've got in front of you, and I'm just going to run through the answers. So the first bit was nice and easy. It's quite chemistry. It's drawing and labelling an atom. Okay. Always remember electrons are in the shells, protons are in the middle with the neutrons, protons are positive. Okay. Why do atoms have no overall charge? That is because proton number always equals the number of electrons. So protons are positive, electrons are negative. Okay. Complete the sentence by deleting the incorrect word. The mass of an atom is concentrated in the nucleus, okay, because the biggest part of the atom is the nucleus where the protons and neutrons are kept. Then a little bit of doing pen. So you've got 11 protons, 11 electrons, because they're always the same. And then neutrons, you have to do 23, take away 11, which would give you 12. Then it's looking at isotopes, okay, and completing the sentence below. Isotopes are the same element. They have the same number of protons, but a different number of neutrons. Most unstable elements tend to decay into other elements and give out radiation. There are 3 types of ionizing radiation: alpha, beta, and gamma. Ignore this question here because you don't need it. Okay. Then it says, what is the units for radioactivity? It's becquerels, BQ. Count rate, the number of radiation counts per second. How would you measure that? Geiger-Müller. Safety precautions when handling radioactive sources: wear gloves, use tongs, wear protective clothing. Okay. Irritation then means you've exposed to a radioactive source, but it's not radioactive. Contamination involves radioactive particles getting into an object. It is contaminated and harmful. Okay. Then you're asked to fill in the table. So alpha, helium nucleus, stopped by paper, range now a few centimetres, but really strong ionising power. Beta then, high-speed electron, stopped by aluminium, few metres, medium ionising power. Gamma, EM radiation, stopped by lead, at least kilometre, weak. Cobalt has an activity of 1,000, a half-life of 5 years. What would the activity be after 10 years? If it is just really quickly, started at 1,000, half of 1,000 would be 500. That would take 5 years. Then another 5 years to get to 250. So this then is a basic decay equation. So carbon 14, which is an isotope of carbon, decays into nitrogen, plus a beta particles given off, okay, and you had to write it out and show what's happened. Beta decay does not cause change in mass of the nucleus, but does cause change of the nucleus, causes the charge of the nucleus to change.